Okay, Algebra 2 skills number 48, measures of central tendency. Let's see what this is all about. All right, so first we have the mean. The mean is also known as the arithmetic mean. There are different kinds of means, but here arithmetic mean, equal distribution of the total. And most everybody could tell you a couple things about the mean. They could tell you that it's also called the average, and they can tell you generally how to find it. You add up all the numbers and divide by how many numbers you have. But what a lot of people cannot tell you is what is the significance of the mean? What is it good for? And we've pretty well said already it's what it is. It's an equal distribution of the total. So if, it makes everything the same amount. Whatever you're measuring, if it's money, if it's height, if it's scores on a test, it makes everything the same. It's an equal distribution of the total that you have. And another fact about the mean is that it can be influenced significantly by an outlier. An outlier is a number which is significantly larger or smaller than the rest of the numbers in the list. So an example of the mean, first a very simple find the mean. To do that, you just add them up and divide by how many you have. Here we have 4 and it's 19.5. So again, to tell you the significance of the mean, it would be as if we have 4 people that have $16, $20, $20, and $22. What if we said that we can't have different amounts of money? We all have to have the same amount of money. Well, if that were the case, this person would give up 50 cents, this person would give up 50 cents, and this person would give up $2.50 so that this person could catch up. Okay, so they would have $19.50 apiece. It's an equal distribution of all that you have. That's the significance of the mean. A better question, or more deep question, would be something like this. Henry makes these 3 scores on his test, but he wants a 90.0 average. What does he need to make on his final test? So a bit of advice to you here is if you're working with the mean and the question asks you something beyond just simply what is the mean, find the total. That's usually helpful. So I'm going to find the total here. If I know that he is taking 4 tests, I'm going to take the desired average. Now here I use the word average, which is a synonym for arithmetic mean, and I multiply by how many I have. So do that. If you know the average ahead of time, multiply by how many you have, that gives you the total. And now we can compute the scores that he has already taken. We know he has 269 points accumulated, so therefore he needs 91 points to get this desired total. So again, if you know the mean ahead of time and you're asking you some question about that, find the total, and that's usually helpful. The median is the middle number of an ordered data set. It does have to be in order. Okay, so to find the median, make sure you put them in order. Usually ascending, though descending is just as good. And it depends on if you have an odd amount or an even amount of data. Odd amount, just simply take the one that's in the middle that has the same number of items on each side. If there's an even amount, you have to average the middle too. Okay, so the median is also less influenced by than the mean by an outlier. So if you have a large number that doesn't seem to belong, or that seems unusually large or small, that doesn't affect the median very much. Third example, find the median. Okay, again, same 4 numbers. Here we have an even amount, 1, 2, 3, 4. So I highlight the middle 2 and I take the average. So I average the middle 2. That is, again, add them up and divide by how many you have. I'm averaging 2 numbers, so I divide by 2. So the median here is 20. Fourth example, create a list of 5 numbers whose median is 10 more than its mean. Okay, so there's different ways of going about this. Just trial and error works. But a systematic way we could do this is to come up with a random mean and find the total from there, like we advised last time. So if we let the mean be 100, the total should be 500, again, because 100 times 5 numbers is 500. And the median, per the problem, should be 10 more than the mean, so we make the median 110. So I created a list of 5. I intentionally put 110 in the middle, keeping in mind that they've got to add to 500. So I need to put 2 numbers that are smaller than 110 or could be equal to 110, but I got to be careful. I don't want to add up. I don't want to make it to where I can't add up to 500. So what I did here was I just put a couple nice round numbers like 50 over here. So I know 50 and 50 makes 100. 100 and 110 is 210. and I split the difference. I need 290 more, so I just made them 145, 145. This is one of many possible answers to this question. The mode is the most frequent number. There can be one mode, as you see in this example. Clearly one number, and I actually have 2 is the mode. So 2 should be highlighted. It shows up more than the other 2. You can have more than one mode. Both the 2 and the 3 are modes here. Or we could have no modes at all. That's when exactly one appearance by each time. Again, 2 should be the mode. That should be highlighted in blue, not the 3. When to use which? If there's no outlier, use the mean. Okay, so that mean is the best representative if there's no outlier. If there is an outlier, or maybe a couple outliers, use the median. And if the list is not numbers, like they're asking favorite color or something like that, you would use the mode. Okay, so example 5, which measure of central tendency would be the best to represent the given list? Okay, here this may be somebody's test, and it looks like they had, they didn't take one, so the mean would be influenced pretty significantly by that 0. So we're going to take the median here. The median would be a better representative. The median would be 90. It would better represent what this person is capable of. But if we have a list, say these are football scores, there isn't one that really stands out as significantly low or high. So it would be better here just to take the mean to equally disperse those scores. And we don't have one for mode because that's really not math. When you're going to use a mode, again, that would be something like favorite color or something like that.